Hello, this is Joe, your chief geek from Ancient Text Research. I want to walk you through the second part in a two-part tutorial that explains how to search for names within ancient texts and how to determine if they are statistically relevant. This video picks up where part 1, the Travis test video, leaves off. In that video, I showed how you could search on a name and verify that the statistics very accurately predict the likelihood of finding that name in any letter sequence. In that particular case, we showed how a name like Travis, the Texan, showed no statistical relevance in our ancient texts. That is, it was expected to show up by happenstance. In this video, we'll show you the statistics of the Timotheus Key and why we think this search term is very statistically relevant. We are going to leave section 4.6 of the user manual and venture into section 13. So everything that I cover here in this video, and I'm going to try to keep this brief because you can go read pretty much everything about statistics and how it's built into the tool and how we use it in section 13. In this particular section, we used a use case from a search term that was sent in to us regarding the Korean atomic holocaust. Very relevant to current events. It was very interesting. Someone sent it in to us the day that, North Korea launched another missile. Okay, and you can walk through that, but a lot of detail and explains how the statistics build and how they're formed and all the different modes, whatnot. I'll go through a little bit of that. You've seen a lot of that in previous videos. The underlying math, how probabilities are calculated based on independent random events. Okay, but I want to be specific and just go right to the Timotheus Key here. One important factor, since we are ending with the Travis Key, is the primary difference of that Timotheus Key and something like a Travis Key is the length at which the Timotheus Key was found. As if you read the book The Chamberlain Key, you'll know it was found at an EDS length of 16, meaning it spans a very small portion of the text. It has 9 characters, and so 9 times 16, 144 characters. It spans 144 characters of the ancient text right in Genesis, a very small section of Scripture. In communications, that's very important because that means if it was very pristine, there was less information that it would have to be repeated. And in communication, we call those rewrite errors over time. We use repeaters. The more repeaters, the more noise that's introduced into your signal, and then recovering it is more difficult. When you have a long EDLS length, you're dealing with a lot more section of the Scripture over chapters and books in which errors can be introduced over different periods of time. And so the likelihood of noise is much greater. And as you can see, the Travis Key span significant lengths. Here's one that, if you're finding terms, results at, 8,302, and you look at, how many books that spans, it's almost unbelievable that you would find anything of relevance in these ancient texts. Another factor regarding the Timotheus Key is its 2 very rare Hebrew characters, and I'll go over that. I have a little PowerPoint at the end that explains some of this. A very important thing for us was having some confidence that the Hebrew version of his name, the author's name, Timothy, he refers to it as Timotheus, the Greek version, but we kind of also said, well, it was Timothy, whatever, we're not Hebrew scholars, but we use Google quite a bit, and you can use our tool to translate that, but you can also just go totally outside the tool, go to Google Translate, and I've pasted it in here. You can do this, and if you do that, you'll see it translates into Timothy. Timothy doesn't exactly translate into that Hebrew term, but the other way does. So I know they did a lot of vetting, the publisher and other scholars, in the translation of that term, but Google at least recognizes that Hebrew term as Timothy, and I can't believe that Random House and the author and Google would have conspired to make that happen. So there's some confidence that that term does represent his name in Hebrew. Okay, so let's actually look at the statistics if he had done a brute force here. And you saw this with the Travis test. I'm going to show you this quickly because that's not actually what he did according to the book. But if you're welcome to do this, you can consider he might have gone 1 to 10,000. And you'll see by doing the statistics on that, we're not going to say a priori, let's just say it was brute force, recalculate. You can go into summary mode. Okay, not in research mode. And it's still pretty rare he's going to find it in a brute force. Actually, we need to change this to all books, as I've done in the previous video. We want it to span the entire Hebrew Bible. Back to statistics here, 1 in 23 chance. Okay, so brute force, he might have found it, but at the time, he just said he found it back in late 90s. He may have not even had a tool to do this. Our tool's only been created in the last few months. He had a different tool, and he may have not even had it at that point. According to the book, he actually was doing it by hand. So let's now visit the statistics in a very small range in which he felt he was directed to look at right in Genesis, because it becomes very, very interesting. But even 1 in 23 for us, remember, 1 in 23 chance means he would have to search 20,000 times and do it 23 times. We'd have to randomize the letter sequence to get a result. Okay, so he still, got a result, and apparently he says he called the shot. All right, so let's play like we're the author, and we're going to search 1 to 16 because he's kind of doing it by hand. And let's change our range to Genesis 30. And by doing this, the character statistics change considerably if you're looking at one. I have to move my screen to clear things out. Let's go to Genesis 30 and select the entire range of that book. Okay, so now let's look at what our statistics become here. 1 in 15 million. Now, we've talked about what we call research mode, and it shows how we build up our statistics. Okay, and you can see that. So in that section, these two rare characters, Tet and Samic, have very low probabilities. But if you choose a priori, meaning it had to be where he said it was in that small section because it all identified with his biographical data, we flip that, recalculate, and it factors this particular character more highly in the individual probability of the event. That's explained a little bit better in the user manual. But the point is, you can see how the character statistics, the individual probabilities, build up into this 1 in 2 billion chance that this particular term would show up in any randomized text with the character distribution of those Hebrew characters. Okay, now I'm going to bring over our analysis from a little PowerPoint, and because we talk about the underlying math, and you've seen this, he called the shot. This wasn't a brute force. Potentially 32 attempts by doing it by hand. These couple rare characters. All right. The tool builds a number much like this. Okay. The underlying math, we treat each event as an independent, mutually exclusive event. So he finds a character, and he determines the next character of his name is 16, a length of 16 characters away. So each character thereafter has to be found at exactly that length. They're independent events. So if you had just a bin of scrambled letters, each event is independent, and they have individual probabilities. So the total probability is the multiplication of each of the individual probabilities. That's how this is calculated, and you can see we have individual probabilities, and the cumulative probability is the multiplication of each additional event factored in, and it continues to build and build and build until you get to this final number here. Okay. Now, when we factor in its biographical data, we use the same calculation. So we looked up to determine what are the chances of having 6 sons and a daughter. And you can do this. You can find the same little chart. You need it, I can probably send you the link. Individuals born in 1950 or before or after the year 2000. I think it's a fair representation. I'm just looking for a rough estimate. It shows that the chance of having 6 sons in a family is 4%, a daughter 12%. So if you have 6 sons and a daughter, it's the multiplication of the two, 0.48% or 0.0048. It's about 1 in 208 families. Now, both he and his father had 6 sons and a daughter. So you have to multiply both of those events times each other. And the chance of that is this number, 2.3 times 10 to the minus 5. And then, of course, we know we have to multiply those events times just finding the key in Genesis 30, where it references 6 sons and a daughter. Combining the probabilities, you multiply the chance of each as independent events, and you get this very, very small number. Very, very small chance, 2.3 times 10 to the minus 17th. What is that number? That is like throwing snake eyes 10 times in a row using a pair of dice for those gamblers out there. 10 to the 17th falls between a quadrillionth and a quintillionth. I got this right from Wikipedia, another source, and you can see that's where that came from. So it's just like rolling snake eyes 10 times in a row. Pretty rare. So here's a summary of the cases for this key. This one really, really does stand out for a lot of reasons, and it would have taken considerable brute force attempts to find it. And we know there was also other biographical data found within the matrix that applies to the author. So you can do some of your own research on that. We hope this helps you. We thank you for your feedback on these videos. We know we're all in this together. And I mean, some of you on one side of the debate, some on the other, but we're all in it together. Again, I hope this helps. And until next time, Godspeed from your chief geek at Ancient Text Research.